Good afternoon, everybody. My name is Nicholas Phillips, and I'm a DevOps engineer working at Balwas. And in this lightning talk, I would like to show you how we adopted GitOps in our company, which is kind of a larger enterprise, I would say. First of all, what is GitOps? GitOps basically means that you store your Kubernetes manifests inside a Git repository, having a mechanism in place which then translates or applies these changes applied to the Git repository to the OpenShift cluster. Actually, GitOps is not really new to the industry. People are doing something like GitOps probably for over a decade. I know our guys in our company are using GitOps for managing their infrastructure using Puppet. So GitOps basically is just a new term for a thing or for a process people are already doing for a pretty long time. But adopting GitOps using OpenShift got easier. And to adopt GitOps with OpenShift, we are using Argo CD. Argo CD is a really cool tool because it makes it really easy to synchronize the YAML manifests you defined inside your Git repository to the OpenShift cluster. So if a developer is pushing a change to the Git repository, a webhook is sent to Argo CD. It then checks out this Git repository, analyzes the differences, and is going to synchronize or apply these changes to OpenShift. Argo CD in itself is basically a Kubernetes operator. And Kubernetes operator typically extend the Kubernetes API through custom resource definitions, or in short, CRD. The most important custom resource definition, which is added by Argo CD, is the so-called application custom resource definition. What it basically allows you to do is to define a source which points to a Git repository and a path inside this Git repository. And then you can define a destination, which basically says in which namespace, or probably better known in OpenShift as project, inside your OpenShift cluster. The good and bad thing about Argo CD is it does not really tell you how you should structure your Git repositories. But on the other hand, it really follows the Unix philosophy, which means it does one thing, and that's particularly well, which is synchronizing your YAMLs stored inside Git to your Kubernetes cluster. But there are certain best practices which should be followed while elaborating GitOps, which is, for instance, to have a separate config repository or have separated the config repository from the source code repository, which means all the environmental specific configuration should be better located somewhere else than your application source code repository, because that allows you to modify the config without triggering a new continuous integration build. If you have something like a microservice architecture in place, where all the multiple components are resided in different Git repositories, you can comprise these services at the same location. And last but not least, you have a cleaner audit log about all the changes happening through your environments. Let's talk about GitOps from the perspective of a platform user. A platform user is either a software engineer or a system engineer. Software engineers typically want to deploy their own applications, and system engineers sometimes deploy off-the-shelf software from external vendors. And they all should want to deploy their applications to multiple environments. For instance, they want to have a test environment and a production environment, and so on. Now, what we defined for us is that each team or domain or value stream gets two config repositories where they can declare their workloads or their YAML manifests, one for production and one for non-production workloads. And we introduced a convention. The convention says that each top-level directory in a config repository corresponds to a namespace or project in OpenShift. So let's have a look at such a config repository here. I have here prepared a demo config repository on GitHub. And as you can see, we currently have a single directory inside this config repository, which is called GitOps test. If I have a look inside of this directory, I see we have a deployment YAML declared, a root, and a service. Now I head over to Argo CD, where I already have prepared the Argo CD configuration so that this directory inside the config repository is synchronized to the OpenShift cluster. And as you can see, the synchronization status is green, which means all the changes applied to the Git repository are already inside my cluster. Now let's have a look inside OpenShift if this is actually true. And as we can see, we have here a namespace or a project which is named the same as the directory inside the config repository. And if I have a look inside of that project, I see we have a deployment which has scheduled a pod, a service, and a root. Now let's have a look if our demo application is actually working. But from the deployment perspective, business applications typically almost always look the same. They consist of the same Kubernetes resources. Most likely they have a deployment, a service which exposes ports from pods to inside the cluster, an ingress object, or maybe better known as root in OpenShift to allow access from outside the cluster. The corresponding pods scheduled by the deployment might use some secrets or config maps for a runtime relevant configuration, or might add a persistent volume claim to store some data. And like 80 to 90% of the applications deployed to OpenShift, the deployment topology looks like this. And to make now it easier for our end users to deploy this set of resources, we provide a Helm chart. Helm basically allows you to template YAML files with a templating language, and you can provide import arguments which then are used inside these template files, and the end result is the rendered YAML, which then can be applied against Kubernetes. And we kind of stole this idea from a talk on YouTube. It's a talk from Ticketmaster. It's called One Chart to Rule Them All. They basically went through the experience that each team developed their own Helm chart and then figured out that best practices were not really shared between the teams. And then they switched it all around. They provided like one chart to rule them all and sticked with this model. I'm not really sure if they're using it today, but we are for sure doing that so. And let's have a look how such a generic chart or one chart to rule them all looks like. I have an example how such a chart can look like here on GitHub. This chart now allows me to easily deploy typically business applications. And what we're now going to do is to migrate the current deployment, which is in place using plain YAML, to this generic chart approach. For this, I'm going to the examples folder, where I have an example how the generic chart can be applied using Argo CD. First of all, I have here a chart.yaml file. There it basically describes that it has a dependency to the generic chart located in this chart repository. And the second file we have is the values YAML. This is probably the more interesting one because it now contains the actual configuration for my application or for my deployment. So what I'm now going to do is I have here the config repository, which I just showed you before, locally. And I simply going to remember the current image deployed. I'm going to throw away all the other resources. Now I'm going to add chart.yaml. Okay. And like all good engineers, I'm going to copy paste this example over here. The chart.yaml. Here I only need to do one modification. Typically, the name of a chart should correspond to the directory name, which is in this case GitOps test. Now I'm going to copy over the values YAML file as well. Now let's have a look. Okay, I just go through over a couple of properties I can configure here. First, in line 2, I can configure the replica count, which then is applied to the deployment. Here I can reference the image. In the network section, this is probably a bit special because you kind of abstracted away a lot of the things you need to configure to get to expose traffic for your pod. Basically, each key of this network field defines a service. And each service has a service port, and if not declared otherwise, this port is used as container port, so the port exposed by the pod as well. And if an ingress section is defined, containing a host field, a route is provided as well, which points to the service, to the corresponding service port. So we really compacted the definition of service, route, and the container port in like a couple of lines away, so people don't need to worry about all the selectors necessary so that the service discovers the pod, and that you need to watch out that the actual container port name is matching the name referenced in the service, and so on. Here I'm defining a simply readiness probe. I guess every pod should have a readiness probe. Readiness probes are pretty important because with readiness probes, your service knows when it can redirect traffic to your pod. So if your pod is still starting up, no traffic is redirected until the readiness probe is successful. And as soon as it's successful, traffic can be redirected to that particular pod. In the last section, we simply define some resource requests and limits, which should also never be missing on a pod because it really helps the default Kubernetes scheduler to select the best node for your workload. So now what I'm going to do is simply apply the image over here and change the hostname to the same it was beforehand, GitOps test apps Balwas.dev. This is simply a wildcard DNS domain entry, which is pointing to the OpenShift router instance. Now I'm going to apply these changes, switch to generic chart, and then we switch over fast to Argo CD, because if I don't find it fast enough, we're going to miss the change. No. Okay, now we're seeing Argo CD already detected the change of the Git repository and now is applying the changes I have defined in the Git repository. And as we can see, the new deployment is already rolling out. The reason why it's a new deployment is because the deployment is named differently. So it kind of cleaned away the old deployments generated through the plain YAML and applied the new configuration. Now, through the generic chart, we are able to enforce certain defaults over all this application. I just picked a simple example, which is that each pod gets, by default, anti-affinity rules. Anti-affinity rules basically make sure that if multiple replicas are defined inside your deployment, that the corresponding pods are not scheduled on the same node. Because without anti-affinity rules, at least in theory, it's possible that multiple replicas, if you only have two, like all of them, are scheduled on the same node. And if this node is going down, your application is going to experience some downtime. And from a platform user perspective, this is kind of already the expected behavior that I have, that if I have multiple replicas, that these are also going to be scheduled on multiple nodes. So now what I'm going to do is, as typical in enterprise environments, I want to have multiple environments for my application. And for this, I'm simply going to copy paste the GitOps test directory and name it GitOps ACC for my now acceptance environment, and make some environmental relevant changes. For example, I name the name of the helper chart ACC, and in this particular example, I only need to change the host name as I don't have a database or anything else behind the scenes. So let's simply commit that to our Git repository as well. Wait until the push is successful. Great. Now, it would be really a pity if we now had to bother operations and ask them, please, can you add a new project in OpenShift, assign role bindings to that particular project, configure the Argo CD application so the GitOps mechanism takes in place. That's basically the reason why we have automated that step of creating new namespaces for our developers. And as you already can see, the new directory, which I just have created, is already deployed or ready inside the OpenShift cluster. And if I have a look, I see the deployment has scheduled 2 pods like I defined, and service and the root are applied as well. Let's have a look if the application is actually available. Okay, it is. Cool. Now you're probably wondering how this is working because there is some behind the scenes magic going on here. And for this, I'm going back to theory to explain how GitOps for operations in our case looks like. As a platform operator, I'm mostly responsible to provide namespaces for the developers, provide role bindings, network policies, limit ranges, quota, and so on. And to make it easy to automate them, we adopted a certain pattern also described by Argo CD. It's called the app of apps pattern. This basically means you have like a Git repository, which has the configuration for all the team config repositories. And in this Git repository, we manage resources like a namespace, an Argo CD applications, role bindings, and network policies. So these are applied automatically. And the relationship between this app of apps repository, we call it apps root config repository, to the team config repository looks like this. The apps root config repository has Argo CD applications pointing to the config repositories. And all we need to do is tell Argo CD, please synchronize the apps root config repository. Then Argo CD gets the information or can discover the corresponding team config repository and then synchronizes the state defined inside the team config repository to the OpenShift cluster. Now let's have a look how such an app of apps repository can look like. There we go. Basically, our app of apps repository is a Helm chart as well. And you see here multiple files, and each of these files corresponds to one config repository. Let's have a look at our GitOps demo config repository configuration. And here we can see I have a configuration which points to the config repository. I have some namespace labels added. So each namespace provisioned through this Git repository gets that particular label. I've enabled a certain set of default resources I would like to have applied, like network policies, limit ranges. And in this section, I configure which user gets access to namespaces provided through this apps root config repository. And on the bottom, I have a list of applications. The list of applications here corresponds to the list of directories I have in my config repository. And we actually have a mechanism in place which updates this list automatically as soon as a new directory is either added or removed from a particular Git repository. Now, you might probably be wondering how we added automatically that entry inside the apps root config repository, or how we're doing that synchronization mechanism. To edit YAML, there are multiple ways to do so. One is, for instance, I saw a blog article at Red Hat which had as an example using sed. I think sed is probably one of the worst tools you can use to edit YAML files, because YAML files have a lot of spaces and a lot of new lines, which makes it really hard to replace certain values using sed. There are other tools available like YQ or certain YAML libraries, but most of them lack a certain kind of support. let's just switch back to our config repository, the lack of support to preserve comments. Most of the libraries to edit YAML remove comments because it's not part of the YAML specification to preserve these comments. So we kind of had to search for a particular library which preserves comments, because if users are going to comment things, we don't really want to remove these comments. And for that reason, we developed the so-called GitOpsCLI. The GitOpsCLI allows us to update YAML values in config repositories easily in our CI system. It allows us to update absolute config repositories, as you just saw, with all apps from the child repositories. It allows us to add pull request comments and to create and delete temporary environments, or how we call it, preview environments, inside the config repository. Just as information, the GitOpsCLI is available on GitHub. If you're wondering, please check it out if you're interested in. There's also good documentation available how you can use the GitOpsCLI to edit YAML inside your Git repositories. But it's a bit opinionated about how we do manage our config repositories, so maybe it might not match in your particular use case. But there's a last thing I would like to show you, and it's the two last features I just mentioned, creating PR comments and adding temporary environments. For this, I just head over to our demo application, so particularly the source code repository, which in that case is simply a website, but could be anything else, a Java application or a Python application. And what I'm now going to do is to edit the index HTML YAML simply through the GitHub UI, because it's, for demonstration purpose, probably the easiest. What I'm going to do is change the title, which was visible beforehand, and simply type hello OpenShift users. And as a good engineer, I'm not directly committing to the master branch. I create a feature branch first. What now happens behind the scenes, we can have a look, is a multi-branch pipeline is triggered. We should see there is now a pipeline run running in our Tectons instance. Actually, in production, we're using Jenkins, but for demo purposes, we're using Tecton today behind the scenes. And the application is built, and the image is then published to our container registry. So what I'm now going to do is create a pull request. In the pull request, we can now have discussion about my changes, and it would be really useful if I now had the option to automatically deploy my branch to a different environment. And as you can see, our friendly bot just sent me a message. They actually can do that by simply adding as a comment /preview. And this is exactly what I'm now going to do. So let's comment that. Just for your information, behind the scenes, these are all webhooks which are triggered to Tecton or sent to Tecton. Tecton then calls the GitOpsCLI and does some magic. Now we should get, in a couple of seconds, a link presented where our newly created preview environment will be available soon. Let's just have a look inside the config repository, what is created behind the scenes. And this is here. We see a new folder is added to that particular config repository. And as you saw beforehand, if I am adding a new folder to our config repositories, the corresponding configuration is automatically deployed to OpenShift. And that's no different for preview environments. The GitOpsCLI basically only takes a template, changes some values, which are environmental specific, and commits these changes in a new directory. And after these changes are applied and committed to Git, the second pipeline, which then synchronizes to the absolute config repository, takes place, and our preview environment should now be available. And I have the change I provided in the index YAML now visible. This feature is particularly useful for front-end developers. It's actually the adoption rate for front-ends is already kind of high in our company using this feature. For backends, it's not limited to front-end. For backends, it's possible as well, but there you have to be a little bit more careful. You need to deploy your own database either with you or make sure that the current database is capable of handling different versions of the application. And after I merge the pull request or close it, the corresponding preview environment then is removed again. That was it from my side for now. I hope I did not take too long. Oh no, I'm actually in time. Here I have a couple of links. I guess the slides will be shared after my talk, so you can have a look at all the stuff. Everything I just showed you is available on GitHub, so if you're interested, you can have a deeper look how everything is working all together. And I would say thanks for your attention.